topic of this video is alkyl halide nomenclature, naming, and reactions that alkanes undergo to become alkyl halides. Well, the rules for naming alkyl halides are the same as alkanes. There's no preference for the halogen, for the halide. As far as numbering goes, it's just chemistry limbo. Whichever numbering system gives you the lowest numbers possible is the way that you number it. So that's a return to the idea of alkane nomenclature that differs from minimizing a double bond or minimizing the hydroxyl group in an alcohol. But what you need to know is that for a chlorine, a bromine, the just write it down, for alkyl halides. For chlorine, you use chloro as the how you would shorten it, shortened to chloro when you name it. For bromine, you use bromo. For iodine, you use iodo. Fluorine, you would use fluoro. Okay, you have that O ending. Okay, so naming. We've got a couple of examples. So I'm going to number 1, 2, 3, 4, 5, 6, 7. And then in green, 1, 2, 3, 4, 5, 6, 7. Well, chemistry limbo, how low can you go? 2 and 5 are lower than 3 and 6. So 2, 5 is how that's going to be numbered. And you assemble the name alphabetically. C comes before M, chloro comes before methyl. So this would be 2 chloro, 5 methyl. The parent, 7 carbons long, heptane. So you use that ANE ending to indicate that it's an alkane, like that alkane ending, but you just name the substituents as chloro, the appropriate halogen name. This next example, you can see that there's more substituents to the left. So I'm going to number 1, 2, 3, 4, 5, 6, 7. Just going to go ahead and that's how it should be numbered. Bromo, B comes before C. So we assemble the name 2 bromo, 3 chloro, 4 methyl, heptane would be how you would name that. Very similar to alkane nomenclature. You just need to know what prefix is proper to use for the alkane, or for the halogen. So reactions, how are alkyl halides made? So if we had the following alkene, the reaction that occurs is if you wanted to brominate to make an alkyl bromide, would be Br2. Okay, for other examples, if you wanted to chlorinate, you would use Cl2, I2, etc. Okay, if you wanted to iodate or chlorinate an alkane, but you use the presence of light. That's the symbol for light. Okay, like ultraviolet light, UV light, or heat. You heat the mixture. And those are the reagents that you use for brominating or halogenating an alkane. Now this differs from an alkene. An alkene, remember, alkenes undergo addition reactions. For the double bond, you have something like this. So in addition, the double bond's broken and you add two halogens. But alkanes undergo substitution. Makes two present, light or heat. Where you call the number of where you have a carbon-hydrogen bond replaced with a carbon-halogen bond. And the major product obeys is similar to Makarnikov's rule, okay, but just stated, for these types of reactions, the major product is a substitution at the highest carbon atom. What I mean by that is that a tertiary carbon atom would be more favored than a secondary carbon atom, which is going to be more favored than a primary carbon atom. Remember, quaternary carbons do not have any carbon-hydrogen bonds. Okay, they're all carbon-carbon bonds, so the substitution doesn't occur there. So in this example, call that's primary carbon, secondary, 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 tertiary, because that carbon's bonded to three other carbons, primary, primary. So the major product is going to be the substitution of a carbon-hydrogen bond. We've got to count those implied carbon-hydrogen bonds with a carbon-bromine bond. The utility of alkyl halides is they can react to make alkenes. As far as, okay, why, does this matter? Alkenes, I guess a workflow as to why this would matter is you can take an alkane, if you have alkane from petroleum, convert them to alkyl halides, and then convert alkyl halides to alkenes. And alkenes you can convert to polymers, as discussed in our earlier video. So even if you have a stockpile of alkanes that you don't want to just burn and convert it into polymer, that's a general process of how you could do it. So why this reaction matters, or how it could matter. So that's how you name alkyl halides. Same rules as alkanes, just use the appropriate prefix depending on the halogen you're using. And then alkanes undergo substitution reactions to become alkyl halides.